How you going, guys? Curtis from Cutting Edge Engineering. So this is our first job for 2023. What we have here is a pair of D10 blade tilt cylinders that have come in for repair. What these cylinders are used for is for tilting the blade left to right on the bulldozer. As you can see, the right-hand cylinder has been cut to pieces in order to disassemble it. So there was a massive failure that went on in there, and the customer cut the head flange off the barrel so they could then retrieve the piston and the gland. There's also a lot of damage on the head gland and also on the piston. And the reason this generally happens, there are two valves in the piston which allows oil to bypass when the cylinder reaches its maximum stroke. Once the cylinder hits its stroke, it pushes that little valve out of the way and allows oil to bypass. But quite often, that little valve will break loose from the piston, it falls down inside the barrel, and then the piston starts to chew it up inside the barrel. The leading cause for these valves getting loose from the piston and getting inside the barrel is the retaining washer that actually holds just the corner of the valve cup, and that little retaining washer is super hard. What generally happens is the machine may be working in some pretty rough terrain, and he might run into something quite hard that doesn't move, and that shock load going back through forces everything to bottom out, so it fractures the corner off the washer, and over time the valve will then start to work its way out of the piston. So this washer is not from this cylinder. The one that came from this cylinder is actually missing a piece, and after it broke out, that allowed that cup to walk its way out of the piston. The valve followed it, and then everything got damaged from there. So this level of damage would have only occurred from continuous operation of the machine, which leads me to believe the operator's not really in sync with his machine, or he doesn't really know what he's doing, because he would have noticed the blade falling over as he was trying to work it because the oil was bypassing through the piston. Considering the amount of damage that is on the right-hand cylinder, the rod is actually intact. There was no damage to the rod at all, and the left-hand barrel has also experienced a failure. The barrel is quite damaged in there from metal going through it. Depending on the configuration of the hydraulic system on the machine, whether the two cylinders actually share oil might explain why we have two failed cylinders, but because they came in as a pair, I'm going to assume they're off the same machine. So when these came in, we had exchange components ready to go. We ended up giving the customer a brand new right-hand cylinder because they needed the piston, the gland, and the barrel. They decided to take the entire cylinder, even though they didn't need a new rod. They've got a brand new one to go back on their machine. We also had a good conditioned left-hand barrel that was sitting on the shelf that they took as well. So now that they're up and going again, we need to get these repaired so we can put them back into our exchange fleet. We will be rebuilding the barrels to go back on our shelf. We don't have the material at the moment, so keep your eye out for a future video where we rebuild those two. We're not going to be repairing the piston. It is way too far gone to repair it. They are cheap enough to buy from the genuine manufacturer or aftermarket parts. Today we are going to be repairing the gland because they are quite expensive to replace. The customer has asked, can we please repair this one, and they're going to put it on their shelf as a spare one for any future repairs they need to do. So what we're going to be using is flame spray in order to build up this area that's all damaged. After that's been built up, we can then throw it in the lathe and machine it back to spec. For this repair, what we need to do is reinstate this O-ring groove. You could just build up the area where the O-ring is going to live, but while we're here, we're going to do the entire repair to make this as close to factory as we can. So all these areas that have got dents in them, we're going to fill all them up and machine it all back nice and flat. There are a few methods you could use in order to repair this. This is cast iron, so you could use a cast iron welding rod, you could use silicon bronze. Some of the issues with welding cast iron, you can run into problems where you do create hard spots where the arc has started and then stopped. They can be difficult to machine out. If the cast iron is not a really good quality, the welding rod just doesn't take to the material very well. It is quite difficult to find a filler material that will stick to it. So my preferred method to repair cast iron, I'm going to use a UTP puddle gun, also known as a flame spray. You can then apply concentrated heat to an area. It adheres really well to the cast iron, and you can then build it from there, and it doesn't create as many hard spots as if you were going to use stick welding or MIG welding. And I also like the puddle gun because you can be very precise on where you put material. You don't have to put a massive layer in there in order to build it up. You can also see if there's any material trying to come, like any impurities trying to come back through the layer you've just put down. you don't leave a big bubble there. You can sort of work that material out. With electrodes, it's quite difficult to do that, especially in cast iron. So the first thing I'm going to do, I'm going to give this a bit of a prep grind. I'm going to remove any material that is being pushed over an edge and is overlapping an area where I need to do a repair. I will then give it a quick wire brush just to remove any loose material from the top. I don't need to do any further cleaning on it because I will be applying the powder to a red hot surface. That is the key to this, is getting it red hot and then applying the powder. Any other impurities or oils will be burnt away before I start to lay the new material. So that's the UTP handpiece setup. You have the main mixing body where you have your two valves for your oxygen and acetylene. That then leads to your trigger for your hopper, which passes the material down through the tip. What these guns do is they allow you to set a heat and it will be consistent. Once you have the job to the correct temperature, you can then pull the trigger, which then allows material down through the hopper. It goes down through the tip and then gets applied onto the job. So I've decided to start with a smaller tip because they don't apply as much material and you don't want to waste it. It is quite expensive. If I find I need more heat or I need more material, I can then upgrade to a larger tip, but I generally start small and then work my way up. So I'm going to be using a machinable grade cast iron powder. That powder, combined with the flame spray technique, it avoids getting hard spots in the parent material that can be difficult to machine later on. So on a part this size, you do want to give it a preheat. Anything smaller, you don't really have to because the heat will disperse through the job and bring everything around it up to temperature. But because this part is so large, if I wasn't to preheat it, it could lead to cracking around the repair zone because the heat will be dissipated through the part very fast. So by bringing the whole part up to temperature, we're going to eliminate that risk of anything cracking. This puddle gun uses oxygen and acetylene as the fuel source. Even though I have preheated the part, I am going to use the concentrated heat from the puddle gun to get it red hot before I apply any material. Now that I've got that area red hot, I can start to apply material. Once that material then turns to a liquid, I know it's then bonded onto the part. I can then move along the job, slowly adding material. If you do apply too much powder, you'll end up with voids and it won't bond to the part. Gravity will then take hold and it will actually fall out of the job. So I'm going to concentrate going back and forward, building up the areas where there's the most material missing. After I get a bit of body back in it, I can then do the finer details, applying material to create a nice even layer.
God.
Righto guys, so the flame spraying process is now complete. Everything went pretty good, pretty happy with how everything was applied. So we're gonna let it cool down just sitting here on the bench. There is no need to wrap it in a blanket. It's not gonna rapidly cool down. It is summer here, so it is very hot today. There is no risk of it cracking because there is no crack through the job. All we did was fill up a void. I've got no drums, that's sitting there for a couple hours to cool off. Once that's cooled, we can throw it in the lathe and get machining.
Hold on. Oh, what? Aha.
What did you get?
It's a harness for a GoPro.
Oh, yeah, right.
You gotta press that top button.
This one here.
It should just start recording.
There we go.
Go.
Righto guys, so that has cooled down now. It's been cooling down for pretty much most of the day. What I'm going to do now, I am going to use a wire wheel just to remove any of the residual dust and metal spray that's stuck to the surfaces. Once I do that, I'll take it over and set it up in the lathe. Right, so you can see where there's basically overspray. This is where it hasn't stuck to anything because it never became molten. We can pretty much chip that off with a cold chisel and a hammer. So I've just thrown a dial on that. It does show that we do have a little bit of run out there. So I'm just going to bump that in with a copper-faced hammer. Hopefully we're going to get that to run a little bit better than what it is now. Because there's no machine surface to reference from and all the other areas have been either flame sprayed or are damaged, I'm just going to make do with what I can. So I've got that running to within 0.03 of a mil, a little bit over 1 thou, which is pretty good considering the state that the gland's in. That's going to be just fine for this application. So what I'm going to do now, I'm going to machine all the surfaces just to clean them up. I'm then going to make sure everything's round and running true and concentric. And then we're going to machine the groove so the O-ring and the backup ring fit in there perfectly. Quick clean-up cut, it's nearly there.
What about that grey mark there?
It's part of the original face. That's where the valve hit it before it blew the valve apart.
Oh.
That's fine. We'll just clean that area there up. Chamfer that. Come in and get that groove. So I'm just going to angle my tool around a little bit more. I want to make the chamfer on the end of the gland a little bit longer, just to help the customer out when they go to install that. It'll give them a nice, easy leading edge for the gland to then go into the barrel. Righto guys, so we've got all those flame spray faces machined back to spec, or as close as they're going to get to spec. There are a few areas in the face of the gland that still have material missing. There is a dint here from where the valve has impacted the back of the gland. There's also a few dints on the other side that I don't know where they came from. It might have been during the disassembly. They're trying to flog it off with a hammer. Those dints and service imperfections aren't going to make any difference to how this functions. The important part of the repair was getting that seal groove back to standard. So we've got that sorted out now, but while it's set up and it's running pretty true, we're just going to skim that just to clean it up. Righto guys, so the repair is basically complete. I'm not entirely happy about this rusty area where the pipe center is, so I'm going to take that out, take it back over to the bench. I'm going to use a conditioning wheel just to remove that rust spot, and then that will just look $1,000,000. Righto guys, that is a repair all completed. I'm really happy with how that turned out. Apart from the colour discoloration between the original gland and the material I added, you would never know that there was a piece of material missing and that it has been repaired. After a couple of 100 hours cycling in the machine, the oil's going to stain that and you would never even know it was there. What I'm going to do now is spray on some rust preventative, strap it down to a pallet and get it back to our customer. Thanks for watching. You ready?
Yep.
How you going guys? Curtis from Cutting Edge Engineering. So today, hopefully we'll get that running a little bit more truer. Hopefully we'll make it run a little bit more true. Is that a word? That's not making English. So there's also a lot of damage. I said cabbage.
And then we'll machine the groove.
Right, and then we'll machine the move. This is extremely damaged. Fuck. Yeah. We're going to let that cool down. After that's cooled down, we're going to let that cool down. Once that's done...
Wow.
Fuck, what was I going to say then? How are we starting that? So, smaller parts you... So the material I'm going to... Fuck off, train.
Someone wrote in a comment, Brisbane to Gold Coast trains are going to increase in frequency.
Fucking serious?
I hope not.
It's like every 15 minutes now. What's it going to be every 7.5 minutes?
Maybe.
Fuck off, train.
Oh.
Fuck off, train. Fuck off, train. Wow, look at all those bits of steel in there. There's part of the valve. That's part of the valve as well.
Okay. Hang on. Can we retry that, please? Are they meant to look mouldy? Oh. Helps if it's new.
Helps if it's in cog.
Jesus Christ. How many endings can we get?
And then that will just look $1,000,000. Then that will just look amazing. And that will just look salubrious. And that repair will then look bonza.
Okay, that'll do. Okay, stop. That's enough. Hey, calm down. No. Wait, you bugger. Just freaking heck. Is it gonna see past your big head?
Here we go.
Hang on, wait, come back. Come back. Hey. He's gone.